In this video, we're going to review the ideal gas law. Here's the formula for the ideal gas law. PV equals nRT. Pressure is always going to be measured in kilopascals for us, which allows us to use this as our R value, 8.314 kilopascal liters moles dot Kelvin. There are other R values, but since we're only going to be dealing with pressures in kPa, this is the only R value we need. And the R is the universal gas constant. So it's a constant value. It'll be on your formula sheet. You just have to remember that you always have the R value. Volume has to be in liters. You need your amount in moles, and you have to have your temperature in Kelvin. But in our last video about gas laws, we reviewed that you always need to have your temperature in kelvins when dealing with gas laws. So let's not forget that. Here's our first example. So we're looking at the Goodyear Blimp, and we have a volume of 2.5 times 10 to the power of 7 liters. And it operates with a temperature of 12 degrees Celsius, to which we're going to add 273. So our temperature is going to be 285 degrees Kelvin, and our pressure is 112 kilopascals. It's asking us for the mass. So you'll note that none of our gas laws have mass. So we can't calculate mass, but we can calculate moles. And then we know how to calculate mass from moles. So our formula is PV equals nRT. So if we want to rearrange that for moles, we would be dividing both sides by RT. And then we can sub our information in. So we have 112 kilopascals. Our volume, 2.5 times 10 to the power of 7 liters. Sorry. All over our R value, 8.314 kilopascal dot liters over moles dot Kelvin, and our temperature 285 degrees Kelvin. So our kelvins will cancel, our liters will cancel, and our kilopascals will cancel, and so we're left with a unit of moles. And when we do that in our calculator, we get 1.18 times 10 to the power of 6 moles. Makes sense that it's a big number because we have a very large volume. So we're going to take that number of moles and we're going to put it into our mass equals moles times molar mass formula. So we have our number of moles, we just calculated it. And we can look up the molar mass for our helium on our periodic table. So we get 4.02 grams per mole. So when we multiply those, the moles cancel. And we get 4.75 times 10 to the power of 6 grams. So that is how many grams of helium are needed to fill that blimp. In our second example, we are given a mass to start with. So we have 10.5 grams of nitrogen gas. It occupies 2 liters, so that's our volume. Our temperature is 125 degrees Celsius. We're going to add 273, so we get 398 degrees Kelvin, and we're being asked for the pressure. So if we're looking for pressure and we have temperature and volume and mass, we always have that R value, it's a constant, but we cannot put 10.5 grams in. So the first thing we need to do is to find our number of moles. So we're going to do that by doing our moles equals mass divided by molar mass formula. So our moles, we have 10.5 grams divided by the molar mass for nitrogen gas, 28.02 grams per mole. So we get 0.375 moles. So now if we have moles, we have temperature, volume, we want to use V equals nRT formula. So if we're looking for pressure, we're going to divide both sides by V to isolate our P. And then we can go ahead and put our information in. So we just calculated that we had 0.375 moles. Our R value is 8.314. kilopascals dot liters over moles dot Kelvin. Our temperature is 398 Kelvin all over our 2 liters. So moles will cancel, kelvins will cancel, liters will cancel, leaving us with a pressure value in kilopascals. And we get 620 kilopascals. So our pressure is 620 kilopascals. So that was a quick review of the ideal gas law. Hopefully that has helped solidify your knowledge.